Click the bell icon to get latest videos from Ekeeda.
Friends, this is the sixth numerical, that is what we are going to talk about, and let us understand the numerical and let's see that is how it is different from that of the previous one. Here the question is, a sample of phosphorus 32 initially shows activity of 1 curie. In this case, the activity it represents, that is the disintegration. So of 1 curie, after 303 days, the activity falls to 1.5 into 10 raised to 4 dps, that is disintegration per second. What is the half-life of, that is the phosphorus 32? So for that we should know what is the value of the decay constant. But here we can't get the decay constant unless we know what is the value of 1 curie. 1 curie in this case, it means 3.7 into 10 raised to 10 dps, that is disintegration per second. So here basically what we have got, that is the sample of phosphorus 32 initially shows the activity, that means it is disintegrated per second, that is with respect to time, of 3.7 into 10 raised to 10 dps, that is the initial activity. And after 303 days, that is, this is the time, that is what we have, that is 303 days. So here let me represent it with t as 303 days. In this case, the D stands for the days. The activity falls to 1.5 into 10 raised to 4 dps. That means the initial disintegration is, that is dn0 divided by dt. It is found to be, that is 1 curie, that is 3.7 into 10 raised to 10. While after a time of 303 days, we have found out that is the disintegration or the particles of the nuclei that has been left, or the number of the nuclei that has been left, is found to be 1.5 into 10 raised to 4 dps. So based on that, we have to calculate the decay constant, as well as we have to finally calculate what is the half-life of the phosphorus 32. So based on all the data, that is what we have, let us find out the decay constant first. Decay constant can be found out with the help of a formula, that is what we know, that is lambda is equals to 2.303 divided by t log to the base 10 of number of nuclei present initially to the number of nuclei after time t. Let me write it as nt over here. So here we can substitute the values. So for that, the time, that is what we know, it is 303 days. So therefore I'll write it over here as 2.303 divided by 303 days log to the base 10 of no, that is, or n naught we can say in that manner, that is n naught, it is found to be, that is 3.7 into 10 raised to 10, while that of the nt, or simply we can call it as capital N, in this case it has been found to be 1.5 into 10 raised to 4, that is the number of nuclei that has been obtained after a particular interval of time, as well as after the decay, that is after the disintegration of that particular element. So this is what we have. And here basically if we calculate this thing, so let's see what is the value of the decay constant is what we could get. But the unit of the decay constant will be day inverse. So now let's find out what is the value of the decay constant here. So here, after calculating all this, we have got a value as 0.0486. So this is what we have got, the value for the decay constant, that is lambda. But here we have to find out the half-life also, and for that we also know the formula, that is how we can calculate the t half by using the value of the decay constant, and the formula is t half, or the half-life, is equals to 0.693 divided by the decay constant, that is lambda. So in that case, basically we have got the value of the decay constant, which is found to be 0.0486 day inverse. That means here basically we could get the value of the half-life, which has a unit of days. So let us calculate this thing and let us see what is the value of T half we have got over here. So after calculating this, we have got a value which is 14.25 days. That is the T half, that is the half-life, is found to be 14.25 days. And this is how basically we can calculate any kind of numerical which is related to the decay constant. Thank you friends for watching this video. I hope you have understood this numerical very clearly, and I hope I'll see you next time. Till then, don't forget to subscribe Ekeeda channel. Thank you so much.